This video covers chapter 21 of the textbook. It's called variation, which is just another name for proportion, and the two types of proportion we're going to be looking at are direct proportion and inverse proportion. So let's look at the main features of these two types of proportion before we get into some problems. So the first thing is that with direct proportion, as one value or quantity increases, so does the other. Okay, so I don't know, for example, the number of hours you work, so hours worked and your pay, yeah, so as the number of hours you work increases, so does your pay. That would be an example of something that's in direct proportion. With inverse proportion, as one value or quantity increases, what happens with the other one? The other value or quantity decreases. Okay, so as one value gets bigger, the other gets smaller. An example of inverse proportion then might be as, let's say you've got a certain job to complete. If you increase the number of people doing that job, let's say building a house, something, the less time it will take, the job will get done in a quicker amount of time. So let's put that as the example, e.g. increasing the workers on a job decreases the completion time. Yeah, so that would be an example of something which is in inverse proportion. Well, what else do we have about these, or what other features do we have for direct and inverse proportion? Well, for direct proportion, if I call one of the quantities x and one of the quantities y, so let's say y, when I do y divided by x, I always get the same value. Okay, so if I put one quantity divided by the other quantity, this bit here is important, by the other quantity, always gives the same answer in a particular problem. Okay, and that answer we're going to call k, and we're going to work out k. Whereas with inverse proportion, it's not about dividing gives you the same number. If you multiply your values, you're always going to get the same answer. So one quantity or value times by the other always gives the same answer. So if you just remember those things, that one is about multiplying and one is about dividing, that should help you remember. Now, how are we going to remember which one is which? Well, direct begins with D, and it's about dividing one quantity by the other, whereas the inverse is about multiply. I can't think of really a way about remembering it. I don't know, I is in the word multiply, and that's what you do, you multiply. Yeah, bit of a weak example, but there we go, there's the I, so that's going to help us remember for inverse proportion. multiply, but divide also has an I in it, so that's probably not the best example. But D for divide, D direct proportion, D divide might help us remember which one is which. And then the other thing to do with direct and inverse proportion is their graphs. Now if you have a graph for direct proportion like this, so if I call this X and Y, it will always be a straight line that goes through the origin. Now it might be steeper than this, it might be less steep, but it will always be a straight line, and it will always go through the origin, goes through the origin. That's 0, 0, goes through 0, 0. Okay, now with inverse proportion, the graphs tend to look like this. Yeah, so they curve down like that. So it's not a straight line, and it's going down. As one value gets bigger, can you see the other one is getting smaller? So it's like this curve, and it's like this decreasing curve. Okay, so it's a curve, and this curve is decreasing like this. Okay, let's get into some examples. Right, it says here y is inversely proportional to x. So it's inverse proportional here, that's important. It says when y is 16, x equals a half. And we've got 3 parts of the question. So let's start with part A. And part A, it says find a formula linking x and y. Now, because it says inversely proportional, I know that when I multiply x and y, I'm always going to get the same answer in this question. I'm going to call that number k. So write x times y equals k. Remember, inverse proportion is about multiplying the 2 letters. Now I need to find k, so that's my next step to get the formula. Now to find k, I take the information that's in the question. And it says when y is 16, x is a half. So basically I replace y with 16 and x is a half. So now I've got x, which is a half, times by k, which is 16. A half times 16, that will give me k. That means that k is 8. So my formula is that x times y equals 8. Now what that means is in this question, whenever I times x and y together, I'm always going to get 8. Now that will help me find the answers to part B and C. So let's go on to part B. It says find y when x is 4. So this is my formula, xy equals 8. And it says find y when x is 4. So all I do is replace x with the number 4. So 4y equals 8. That's very easy to solve. Y equals 2. Okay, so the 2 numbers I know need to multiply to make 8 because of what was given in the question, things that I've underlined in green, and it's always going to be equal to 8 in this question. So if x is 4, y needs to be 2. And then in part C, find x when y is 20. So again, we'll start with the formula that we've got. X times y is always equal to 8. So if y is equal to 20, I basically have x times 20, which is 20x, equals 8. So I'm going to solve that. And the way to solve that is x is going to be 8 divided by 20, which I could just simplify if I wanted to by dividing the top and the bottom by 4, I think, to give you 2 over 5. Or I could actually leave the answer as the fraction 8 divided by 20. It's 2/5 or 0.4. So 2/5, or I could put 0.4. So it's as easy as that. So since it was inverse proportion, it is about the numbers that multiply. Right, here's another example. It says that y is directly proportional. Okay, so this is about dividing to the square root of x. When y equals 2, x equals 36. Find x when y equals 5. So the first thing is that because it's about dividing, I know that y divided by, now it doesn't say x, it says the square root of x, I'll write that down. So y divided by the square root of x is always going to give me the same number in this question. So now I need to find k, and the way that I'm going to find k is by using this information that's been given here. I'll underline it in green. So I replace y with 2 and x with 36, so it's the square root of 36. That's what k equals. So that's going to be 2 over 6, and if I simplify that, k equals a third. So the formula that I'm going to use is that when I do y divided by the square root of x, I always get 1/3. Now when you do these questions, it is really important that you write down this to start, then you do your working, then you write down your formula. Yeah, we need to find k to find the formula, and in this case we divide to find k. So now I can answer the question. It says that when find x when y is 5. So I'm going to use this formula here, and what do? I need to find x when y is 5. So I have 5 over the square root of x equals a third. Okay, we're not going to round or change that to a decimal. So now we want to solve this equation. So what I can do is I can multiply both sides by 3 and then divide both sides by or multiply both sides by the square root of x. So effectively what I'm doing is I'm multiplying these two together, and that's going to be equal to these two multiplied together. It's called cross multiplying. That's something that we can do. If you're not sure about it, then you start by multiplying both sides by 3 and then multiplying both sides by the square root of x, and what you'll end up with is 15 equals the square root of x. So if I need to find x, I need to square both sides. So x equals 15 squared, so it's 225. So there's my final answer, that when y is 5, x is 225. Okay, here's another example. It says y is inversely proportional. Okay, so this is going to be about the multiplying the x and y to the square of x. So it's not just x, it's the square of x. That actually means x squared, not the square root of x. That means x squared. When y is 3, x equals 12. Find x when y equals 27. Right, so the first thing, because it's about inverse proportion, I know that when I multiply y and x squared, y times x squared is going to give me a fixed number called k. Yeah, and we're going to find that number. So remember, we always write that down. Our next step now is to find out what k is. And to find out what k is, we use this information here. So the stuff that I'm highlighting in green there. Right, so we substitute y for 3 and x for 12. That's what k equals. So we just need to work out 3 times 12 squared. So 12 squared is 144. Times that by 3, I get 432. So k equals 432. So that goes back into the formula that I did in the red box, but now with 432 in there. So yx squared, or x squared y, is always going to be 432 for this question. Okay, so we're going to use that to now finish off the question, and the question says find x when y is 27. So we use our formula. I replace y with 27. So 27 times x squared, or 27x squared, equals 432. So you should know that if I want to find x squared, I divide both sides by 27. So 432 divided by 27. Let's see what we get for x squared. Hopefully it's a nice number. 432 divided by 27. 16. So x squared is 16. So to find x our square root, so x equals 4, so there's my final answer. Okay, on this one here it says w is directly proportional to y. Okay, so directly proportional, we need to be thinking of a division, probably w divided by y. And it says when y equals 4, w equals 14, so that's going to help us work out what k is, and then we can use the formula to finish off the question. So w is directly proportional to y. That's going to equal a number k, which we're going to work out. How are we going to work it out? By using the values I've underlined in green, 14 and 4, to get k. Now k is not always a whole number, it can be a decimal or a fraction. Now you don't, if it's a fraction, leave it as a fraction. You don't need to change it to like a long decimal. If it's a funny fraction, leave it as the funny fraction. So here I'll get 7 over 2, which is 3.5. So let's write it as 3.5. So I'll write my final formula. W divided by y is always going to give me 3.5 in this question. Then it says work out the value of w when y is 9. So all I do is I replace it from my formula, which is here. Just take that formula and replace y with the number 9. So w divided by 9 is 3.5. That's easy to solve. W is going to be 3.5 times by 9. Gives me a final answer of w equals, let's work that out, 3.5 times by 9. Get 63 over 2, which is 31.5. Again, you can leave your answer as a fraction. That's totally acceptable. So there's my final answer. Okay, these two questions look slightly different. They work in the same way, we just need to complete these tables. So the first one, it says that h is directly proportional, so direct divide. H is directly proportional to t, complete the table. So that means dividing. Now, I can either do h divided by t or t divided by h to find k. Now, I'm going to do h divided by t simply because it's doing the bigger number divided by the smaller number. Okay, now it doesn't matter which way around I do it. So h divided by t will give me k. Now what I do is I use the information in the first column here, because I have both of those values. I have h and t, can't use anywhere else in the table. So to find k, it's going to be 29.4 divided by 3. So let's work that out. 29.4 divided by 3. I get 49 over 5, which is 9.8. Okay, so the formula is, that's k by the way. So the formula is h divided by t is always going to give me 9.8. In other words, if I do the number at the bottom divided by the number at the top, I find I should get 9.8. So this one here, if I want to work that out, so the number at the bottom is missing, h, but I know if I divide it by t, which is 4, I'll get 9.8. So that means that the value of h is 9.8 times by 4. Work that out, 9.8 times by 4. So the missing number is 39.2. So 39.2. In the next part of the table here, if I want to find this, so I know that h, which is 58.8, divided by t, that's what I want to find, is equal to 9.8. Okay, now what will happen with this, if I times both sides by t, then divide both sides by 9.8, I'll get t equals 58.8 divided by 9.8 to find t. So let's work that out. 58.8 divided by 9.8. I get exactly 6. So I'll put that in. And then the last one here that goes in that box. So I'm trying to find t. So I've got h 88.2 divided by t is 9.8 again. Again, when I rearrange that, I'll get t equals 88.2 divided by 9.8. So I've left out a step of the rearranging. And 88.2 divided by 9.8, and I get exactly 9. Okay, so that's the direct proportion. Now on the inverse proportion table, this is actually even easier to fill in because we know proportion is about multiplying. So I know that when I do u times v, I'm going to get a fixed number k. So I can use what's in the first column to get that. So 2 times by 6.8 will give me k. So 2 times by 6.8, that gives me 13.6. Okay, so the formula is u times by v is always 13.6. So I know that when I multiply every column, because it's inversely proportional, it has to be 13.6, which means if one number gets bigger, the other one's got to get smaller to keep the value at 13.6. So this is really easy. So all I've got to do is divide each of the numbers by 13.6. So first one, 13.6, and divide that by 3.4, missing number 4, easy. Next one, 13.6 divided by 1.7, I get 8, easy. Next one, 13.6 divided by 0.8 is 17. Easy, easy, easy. Okay, you should now be able to do problems to do with direct and inverse proportion. So just as a quick recap, direct proportion is going to be this type of thing, or it might be if it says y is directly proportional to x squared, or y is directly proportional to the square root of x. It could be anything. It could be y is directly proportional to x cubed or the cube root of x. Yeah, anything like that. So that's direct proportion. Inverse proportion is going to be, well, they multiply to give you this value k, which we need to find. It could be that y is inversely proportional to the square of x, x squared. It could be x is proportional to the square root of y. Yeah, but it's always multiplying. It could be all sorts of different things. So something like this will be y is inversely proportional to the cube root of x. Okay, and our direct proportion graphs are always going to be straight lines that go through the origin like this, and our inverse proportion, yeah, they tend to be graphs that look like this, and you may need to actually pinpoint and choose which graphs go with what. So you may have like different types of graphs, and what you need to do is to say, right, okay, which one is the graph of x squared, which one is the graph of the inverse proportion, all that type of stuff. Okay.